So we're doing this warm-up and we're recording it to clarify certain points here. There are certain times when we could actually combine like terms, and there's certain times that we could multiply where the exponents change. Number one, you have 3x plus 2x. What's the answer? 5x. Easy, right? You have 3 little plastic x's. You have 2 more little plastic x's. You're going to have a total of 5 little plastic x's, right? $3 plus $2 is $5. Now compare that with the next one, 3x times 2x. That answer is 6x squared. 6x squared. I mean, technically, you could rewrite the 3x times 2x. That's really a 3 times x times 2 times x. So that's really a 3 times 2 times x times x. This is a total waste of time, though. You already know your answer is going to be 6x squared. My point in doing this is to show you that on the first one, we're adding, exponents do not change. Hi. And on the second one, we're multiplying, exponents do change. So on number 2, we are changing exponents. On number 1, we are not. On number 3, we have 3x squared plus 2x to the third. So what's happening there?
Nothing.
Are we able to combine like terms? No, because they are not like terms. So the only thing we could do is at least rearrange it in the correct order. And what would the correct order be? Standard form. 2x to the third plus 3x squared. At least now it's in standard form. How about for reviewing previous lessons? Does anybody remember what the degree is?
3.
3, excellent. How about leading coefficient? 2. How about the coefficient of x squared? 3, that's right. How about constant? There is no constant, right? You could put plus 0 if you want, but there is no constant on this one. How about if you wanted to classify it first and last name? Maybe I'm stretching it here. Cubic binomial. Excellent. All right, still remember what we learned before. Great. Moving on. Now, number 3, we were not able to add them because they were not like terms or different terms, so you can't add them. You could just rewrite it and put it in order. Number 4, we are multiplying. So right there, you could do a rearranging, and we could get what answer on number 4? 6x to the 5th power. Excellent. 6x to the 5th power. Okay? So you're probably thinking, well, why do we do such basic questions right here on the warm-up? That's just to clarify, to be absolutely sure when we get types of questions. All right? Sometimes we make mistakes. It's simple distribution, right? So right here we do have a binomial times a trinomial. So I always like to cover up the term I'm not distributing. All right, so we're going to distribute the 2x to the third. 2x to the third times 3x squared is 6x to the 5th. Okay, and then we go 2x to the third times negative, and you could put a 1 right here if you want. What's 2x to the third times negative 1x? Negative 2x to the 4th power. Okay. And we still need to distribute the 2x to the third to the last one, minus 2. Negative 4x to the third. Okay. Now, at this point, we've already distributed the 2x to the third. Now, let's distribute the negative 3. All right? When I'm on the board, I usually use my hand to cover it up. Right here, I'm using the little box. So let's distribute that negative 3. And you could go negative 3 times 3x squared. Negative 9x squared, right? A negative times positive negative. Now you could write it over here, negative 9x squared, and I will write it over there, negative 9x squared. And let me continue on here. Negative 3 times negative 1x, what do we get? Positive 3x. And negative 3 times negative 2? Positive 6 plus 6, there we go. So we have this huge polynomial. And you always have to ask yourself if you could combine anything. and there's absolutely nothing to combine. Power of 5, there is no other powers of 5. It's already in standard form. Highest exponent, power of 5, power of 4, power of 3, power of 2, power of 1, and the constant at the very end. So there is nothing else to do. Most of the time, after distributing, you'll be able to combine like terms. In this case, there is nothing to combine, so that's your final, long, disgusting answer. That would be a quintic polynomial. Let's move on to today's lesson. 8.4. Please write this down. Special products. Now, what we mean by special products is when you multiply a binomial with itself, right? So let's say we had x plus 3 squared. This is what we would consider a special product. Now, there are certain patterns that we're going to go over, memorize, and apply. But you don't have to apply these patterns that we're going to be talking about. You could just write it out and do it the way we always do. Because when you have x plus 3 squared, that's really x plus 3 times x plus 3, correct? And then we're going to distribute. Let's distribute one at a time. X times x, x squared. X times 3, 3x. 3 times x, positive 3x. And 3 times 3, 9 plus 9. And at the very end, we're going to combine like terms. And the middle term, x squared plus what? When you combine 3x plus 3x. 6x. And bring down the plus 9. Okay? So that's the answer. We already knew how to do that. But in this section, they want us to go over this pattern that if you have a plus b squared, you could jump to this where your answer is going to be a squared plus 2 times ab plus b squared. Okay? So the problem that we just did was x plus 3 squared, right? Yeah. Okay? So using this pattern that they want us to learn, we're going to take this first part of our answer is going to be a squared. So whatever's here, you just square it. So right here, x squared, what's that going to be? It's going to be x squared, right? And then the middle part of our answer is going to be 2 times a times b. So if I did multiply a times b, what's x times 3? 3x. And if we multiplied it by 2? 6x. So we'd get plus 6x, right? And at the very end, the last part of our answer, b squared, that would be 3 squared. What's 3 squared? That's 9. Okay, so there's your answer. As you could see, whoa. So as you can see, guys, this pattern is not necessary. You don't need to memorize this, right? I actually don't really use this pattern. I like writing it out and distributing and combining like terms, okay? Now, but there's this other pattern that does make things a lot easier. The other pattern is when you have something like a binomial, let's say x plus 3, times the same binomial, but with the sign changed, x minus 3, okay? Let's actually work this through and see how we would normally do it, right? With our skills, our old skills right here. We're going to go x times x. What do we get? X squared. X times negative 3? Negative 3x. And then positive 3 times x plus 3x, and positive 3 times negative 3? Negative 9. So what happens with those middle terms? They combine, which means that one's negative, one's positive. They cancel. Okay? So the answer is x squared minus 9. Okay? So the shortcut that they want us to learn in this situation is this. When you have a binomial, a plus b, and you multiply it by the same a and b value, but with a sign change in the middle of your binomial, then you know that your middle terms will cancel out, right? Your middle terms will cancel out. So all you have to worry about is doing the a times a, which is a squared part, with the minus sign in between, and the b times b at the end, which would be the b squared part. So the middle terms always cancel out. So this one does come in handy. The first pattern I don't use so much. This one, yeah, I always use this one. If I know that I have a binomial with the same exact binomial but with the sign change in the middle, I know that those middle values will cancel out when I combine like terms. Okay? So how about this? Let's try one of these. Now let's come up with any binomial. Let's go with give me a number. 5x. You guys want a power on the x?
No.
Squared. Sure, why not? And then minus 7. Let's keep it a little easy. Sure, why not? Okay, now let's take that same binomial and rewrite it. 5x squared plus 7. Just change that middle sign. So if I gave you this problem to simplify, you could do it the old way, right? Distributing and then combining like terms. But at the end of it all, you know that your middle terms are going to cancel out. So this shortcut that they give us right here is simply taking your a value and squaring it. So let's think about this. What would 5x squared times 5x squared be? 25x to the fourth. Okay? And let's look at our last term, the b squared value. What would 7 squared be? 49. And you just simply put a minus sign in between it and you're done. That's your answer right there. 25x to the fourth minus 49. Right? Now, even if you don't want to learn this shortcut, after doing the long method so many times, you're going to come up with a shortcut on your own anyway. Check it out. Let's say you distributed 5x squared times 5x squared, 25x squared. 5x squared times 7, that's 35x squared. And then if you distribute negative 7 times 5x squared, that's negative 35x squared. And negative 7 times positive 7, negative 49. And then you're going to see that the middle terms, when you combine them, they're complete opposites, which means they cancel out. And after doing that several times, you're going to start recognizing this shortcut pattern anyway. Okay? So if you don't want to apply it right away, you want to go the long route, go for it. You're going to eventually kick into this mode where you cancel out the middle terms automatically. But you're going to see it happen whether you're doing it the long way or you're trying to apply this new shortcut. And that's what we're going to be practicing today on our homework assignment right here in class.